Hello, my name is Bella Ormerod. I'm a marine data engineer here at OceanWise. And I'm just going to talk a bit about marine mapping and who uses it and the products that are available with Digimap. So I thought to start with, we could just sort of talk about the ocean, get in the swing of it, get some facts out of the way. So the oceans cover 70% of the Earth's surface and contain 97% of all water on Earth. Given that, it's unsurprising to know that the oceans are significant assets that contribute 1.27 trillion euros to the global economy every year. This is a value that is rising and is projected to continue to rise. 27.3% of the ocean floor has now been mapped to the highest modern standards. 27% might sound pretty low, but when you consider in 2017, this was only 6%. We've done pretty well in the last 10 years. It's also worth understanding that when we talk about the highest modern standards, far more of the ocean has been mapped to a pretty good standard, but we're talking about being able to say that we really confidently understand what is in that location when we talk about the highest modern standards. And finally, the coastal zone is one of the most difficult areas to map. It becomes too shallow for usual bathymetric surveys. It's hard to get the boats in there, but it's too deep to get in there from the land. And this is a gap that's known as the white ribbon. It's very hard to say actually how much the white ribbon has been mapped. I think it's a lot more than many people think it is. And with developments in technology, our ability to map it is improving a lot, especially with things like remote vessels, which draw a lot less and get in much shallower waters. But it's often overlooked that actually the area closest to home is one of the most difficult bits to map. So who are OceanWise? OceanWise are a leading provider of marine mapping products and services to governments, ports, harbours, offshore energy within GIS and online mapping. OceanWise provide monitoring systems for real-time tidal, meteorological and wave data to ports and offshore energy, and support compliance through data management training, asset management and enterprise solutions. Looking specifically at the mapping side, the focus is really on providing intelligent marine mapping. This means mapping that is authoritative, is flexible, is compatible, and is easily integrated. In an increasingly digital world, it's really important that mapping continues to just be a way of presenting data in an accessible format. We need it to not be tied to specific software companies. We need it to be not reliant on someone being an expert in computers or an expert in GIS or in mapping. It needs to just be something that they can get hold of and use. Who's using marine mapping? Lots of people, lots of sectors, many more than many people would really think. We don't need to necessarily look at every single one, but of course, much of the room today is education and academic institutions. And then many of the other sectors that we work with often are governments and agencies, marine transportation, ports, harbours, offshore energy, telecoms, environment, and coastal protection. To look at the mapping products in particular, especially the ones we're providing to Digimap, the first one to look at is Raster Charts XL. So XL stands for excluding land. A raster chart is a flat image map chart. It's essentially a digital version of what some people might know as a paper chart, except unlike a paper chart, it's not been cut up into pieces the size of a piece of paper. It's a continuous map. And we've also cut out the land. So it's often used as a base map, most commonly used paired with terrestrial base mapping. So what I've done here is paired it with OpenStreetMap, and you can see especially around the harbour where it becomes really valuable because you can move from your sea mapping to your land mapping seamlessly. You don't create what would essentially be another white ribbon situation. This is available on Digimap, both online and via WMS. So in this case, I've taken it as the WMS and opened it in my GIS software to be able to add in other layers, other base mapping to go with it. The next product would be marine themes. So much like the raster charts, this is mapping our oceans. However, this differs in that it's not that single layer image. This is a vector data set. So there's multiple layers and multiple features within each layer that can be turned on and off. So you can take the data set and create the map that you want to see depending on the work that you're doing. It's important to understand also that where this really differs from a raster chart is often made with sort of navigation in mind. So it includes everything that's relevant to navigation, but they don't want to clutter it up with things that have no relevance to navigation. Whereas in marine themes, that clutter is not a problem because we can turn things off. So everything's included. So for example, in a raster chart, you include all the wrecks that are hazardous. In marine themes, you include all the wrecks, full stop. This might be a wreck that's 100 meters down, it might be buried in mud, it's still going to be included. In marine themes, you can also query an individual feature. So what I've done here is I've clicked on one of these wrecks and I can find out that the vessel's name was Salvestria. I can tell you it's a dangerous wreck, so that means it's hazardous to navigation. And I can find out lots of other information to go with it, which again, you wouldn't get in a raster chart, but the payoff is it's a much bigger data set. So this one is also available through Marine Digimap and also as a WMS. And the data all comes from hydrographic officers and then is supplemented by other official sources. So other sort of like boundary data sets and things like that. And then we have our digital elevation model, a DEM. So this is showing the depth of the seabed and is built using the highest resolution survey data available. That's also, so the highest resolution and most recent survey data. And we have this available in two scales. We have 1 arcsecond and 6 arcsecond. So when we're talking about arcseconds, we're talking subsections of ultimately like degrees of latitude, longitude. So we're talking a distance. We can translate that roughly to 1 arcsecond might be about 30 meters of resolution and 6 arcsecond about 180 meters of resolution. Obviously, those meter translations are going to change with where you are in your latitude, but as a rough translation for the area that we're in, you'll be around there. We have two scales because when you're talking about DEM data, you're talking quite big data sets. And if you're starting to download a whole country in 1 arcsecond data, you're going to have to handle a lot of data. You're going to have to load up a lot of data. So you might want to start with your 6 arcsecond to get like the grips of where you are, and then zoom in on certain areas with your 1 arcsecond. And then you don't have to handle quite so much data. When you download the data, it comes as tiles. So your 1 arcsecond will come as a ½ degree tile, so ½ degree of lat and long. And then your 6 arcsecond is 2 degree tiles. So of course that means for every 6 arcsecond tile, you're downloading 4 1 arcsecond tiles. So again, it's just another thing to consider when you're coming to download data is, do I want the highest resolution at the payoff of having to download 4 times as many files for the same data set? I thought it'd be nice to look at what some of our customers are doing with data because some of them are doing really great things, this one in particular. So this is Welsh Government, and they wanted to make an open access portal to map strategic resources in Welsh waters. So this is things like renewable energy sites, aquaculture, fish farms, ports and shipping. And because it was open access, of course, it needs to be accessible, it needs to be understandable, the same things we were talking about earlier. In order to do this, they have taken in our DEM and marine themes, and then also supplemented it with various other bits of data that they have themselves. And it's created this really great portal where you can turn layers on and off, depending on what you're wanting to look at. And it's a really cohesive understanding of what's happening in Welsh waters. So for example, here I've just turned on wind turbines and submarine cables. And I can even see specifically that these are power cables, unsurprisingly from turbines, but I can see where they're going to every single individual turbine, and I can see where they're going further afield as well. I've included the link to the portal just because I think it's quite fun to look around if anyone has similar interests to me. It's a good one to go and have a look at what they're doing with the data. And then this is Vattenfall. So Vattenfall are an offshore energy company, specifically working in wind energy. And they have an organizational WebGIS system where they can monitor various assets. I think they even monitor things like vessel tracking and AIS. So they largely use RCXL and use it as base mapping. But especially where with wind farms, you have cables running from the sea onto the land, they need base mapping that will do the same. So that's where RCXL really comes into its own. They have base mapping from RCXL working seamlessly with their terrestrial base mapping, and they can run their cable lines and their GIS system going straight across. And again, they don't have that gap in the mapping. They can always be confident in the location of where they're working. They also can use the mapping for other reasons. So they like to use it to understand the sort of full characteristics of environments that they're working in, especially when they're planning new developments. They can actually get a good idea of all the things they might expect and find a few less surprises along the way. And then even further afield, they can use it to identify potential new sites. You can gain a lot by not having to always go on site and see things. And the more information and mapping you have available to you, the less time you waste on sort of full starts. So actually having that information available to them is really helpful for that reason. So that's the end of my presentation. I think Denise is going to say some bits, but I'm very happy to answer any questions anyone might have.
Okay, so when you get into Digimap, all your collections will be displayed here on the top, and you can click on the collection that you want to work at that moment. So in my case, I will click on Marine, and I can see a little bit about the Marine collection, where it comes from, and little tips on how to get started, subscribing and logging in and so on, and some FAQs. Of course, you'll find much more of this in the help pages, which is right on the top right of your screen. So let me go back to about. On the right side of your screen, you have the chart web services and the marine web services. If you click on them, you'll see that there is a link, and if you copy the link and add to another collection or to your GIS collection, you will be able to import the marine collection into the other collection. And you can do that as well the other way around. You can take data from other collections and import in the marine if you want to work with the data from different sources. So going back to the marine. So the marine web services will allow you to add your marine vector, marine themed vector to other collection, and the chart web services will allow you to add the raster chart to other collections. And on the top, you have Marine Digimap, and that's where we are going now. So when you click on Marine Digimap, you will open the interface. You open Digimap interface, and you can see that all that is covered is the waters here around the UK. You can zoom in and out by using your scrolling wheel on your mouse, or you can use the bar around here to zoom in and out as well. So let's zoom in, and we can also pan your map and drag and place wherever you want. I think this is quite a nice busy area for us to take a look. I'm zooming in quite a lot. And if I click on the base maps, which is here within the screen, I can choose either the themed vector map or the raster charts. So if I click on the raster charts, that's what I'm going to be seeing. That's what I will be able to look at in my map. And if I click on the theme vector, I will see the shipwreck and a different set of data. So you can choose according to the data you are working with. You can see the map content, and you can tick. If it is the vector map, you can actually tick on what you want to display in your map. You can either show all the layers or you can pick different layers and different sub-layers within the layer that you are picking, and it will show just the layers that you choose to see. If you are on the raster, this is not available. You can't pick the layers. You will see what is on the screen, but you can choose if it's in the vector. You can also see the maps that you've saved. So you can save your map even when you use the drawing tools to create symbols and the comments on your map. You can save your map with the symbols, with the comments in them. So you can add things to your map and save, and then you can open whenever you want, whenever you need. You can create folders. It will work in the same way as a folder system works in Microsoft, for example. And you have the overlays. So I have administrative overlays that I can choose. I have industrial, Tridal, and each of the overlays I can choose the transparency level. So if they are overlapping, I can adjust the transition or the transparency level so that I can see all of them. Shipping and transport. So I can choose the overlays I want to display on my map, or I can leave with none. And I can use the drawing tool, as I said before, to add markers on my map so that I can identify and even name. Let's say I'm trying to identify a shipwreck and I know how this one is called. I will just add a text, add a label, ASL. That is just an illustration. I don't actually know what it's called. So I can do many activities with my map. I can create a polygon to identify areas, so deeper water areas, or you will choose what you are working on. I can use different color scheme to map my area. I can measure distance between land, and so I will just draw a line and then I click on the measurement tool. When I click on my line, it will measure the distance. I can measure the area of a polygon that I've created as well. And all these will hopefully enhance your research and let you see and make annotations on your map, and you don't need to print it out and write by hand on a piece of paper. You can make all your annotations on the map. You can, if you have images, if you have photos that you have downloaded in your computer, you can add those images to the map as well. Just click on the camera and upload your image, and the image will appear on the camera. You can use the buffer tool to measure the area, or even a line buffer that will allow you to measure currents, for example. And you just need to choose your radius. So let's say if I want 10 kilometers or 10 miles radius on a line buffer, I will click, and at the end it will show me the radius I want. If I find that this is too much, I should have chosen 5 instead of 10. I can delete. Either I can delete all my drawings, or I can delete by clicking, or I can select and delete. So I will this time delete by clicking. I just click on there, and then when I click anywhere in my map, the drawing will delete. So those are the drawing tools. And here, once you select a tool, so let's say I selected my polygon, I will be able to modify. I can make it larger, smaller. I can rotate it and modify points, for example. So this is the drawing tools, and the aim is to make your research easier, your annotations easier, so that you don't have to print and do that on a piece of paper. You can use the interface to do that. You can just use the measuring tools here, and you can identify places in your map. So whenever I move my cursor, it will move the information as well. So if I want to target some specific information like this shipwreck here, I can just click on coordinate capture and it will stop moving. So I have the correct numbers, so the correct coordinates for that shipwreck. And I can download data from my map. So I have the vector data, which is the marine theme vector, and I have the raster charts, and I also have the marine dam and arc. To download data, I will first choose the data I want, and I can either draw a rectangle or a polygon or a buffer, or I can use coordinates, select visible areas, use tile names, import polygons. So there are many different ways you can select the data you want to download. To keep it simple for this demonstration, I will just choose a rectangle. I will click at the end, and I will click at the beginning and at the end of my rectangle. It's formed. Then I can go and choose what data I want to download. So for the vector, there is no limit in the data I can download. And for the raster, for example, there are tiles that I can download. So if I click on this one, I can download up to 30 tiles. So I'm on 7, I'm fine. If I try to download too much, it will appear in red and I won't be able to. Not at once, but you can download in pieces and then put them all together in GIS. And you can see the availability grid. So when you click on those little squares here, and whatever turns pink in my map is what I have available for download. So you can see I have a lot of data here I can download. So that is not going to be a problem. I can display 2 maps as well. And I can have, for example, one in vector, one in raster. So that one is in vector. I use this one in raster and I can compare them. And I will click again and it will disappear. So I have my data that I want to download. I just add to basket and choose which update I want to download. By default, you will see always the last update. And I will keep on that one. And request download. So you will receive an email with your download and your data, and you can use on your GIS system, for example. So this is more or less what you can do, and you can see. You can also check your previous downloads. You can go to the help page, and you can print what you see in your map, for example. If I click on this eye, and I click on the map, all the features, all the properties of the place where I'm clicking on will appear, and you can see all the attributes of your data in this little area here. So that's more or less what I wanted to show you, and how you go about. If you want more detailed tutorial on the functionalities and the tools of Digimap, don't miss one of our Getting Started with Digimap, which is offered every second month, and you will be able to see in more details all the functionalities, all the tools that we can do. So you just need to go to our Digimap blog, and you'll be able to see when the next webinar is. It's this little pen here on the top. When you click on that, you will see all the next webinars, and you'll be able to sign up to them as well. So that's me for now. I will just stop sharing and start answering the questions that you may have in the chat. Thank you.